This video will explore key parts of a 3D printer, review the filaments that we use, and compare and contrast when to use each of the 3D printers. We're going to explore two 3D printers that our team uses. One is the Prusa i3 MK3, which is owned by the team. The other printer is a Hevo, a Hypercube Evolution, built and owned by our coach. First, the Prusa is a Cartesian printer with the y-axis moving back and forth on the bed, the x-axis moving side to side on the bar, and finally the z-axis moving the bar up and down. It has a print area of approximately 8 inches cubed. The Hevo is also a Cartesian printer with the x and y-axis moving back and forth using a belt system. For the z-axis, the extruder does not move up and down. Instead, the bed moves up and down. The Hevo has a print area of approximately 21 inches cubed. Print bed. The Prusa has a flexible plate that makes it trivial to remove prints. The Prusa print bed is heated to help with print bed adhesion and to reduce warping. The Hevo does not have a heated bed, but since we just print with PLA, a heated bed is not needed. The Hevo has a glass print bed because a nearly 2 foot by 2 foot flexible print surface would be prohibitively expensive. When printing other materials such as PETG or carbon fiber infused nylon, we need a heated bed and therefore we use the Prusa. Bed leveling. The Prusa uses a magnetic proximity sensor to determine the distance between the nozzle and the bed in 9 points, forming a grid on the bed. It then makes micro adjustments to the print height to account for small variances. This is called mesh bed leveling. The Hevo has a mechanical bed leveling between the 4 Z-axis lead screws as well as a 49-point mesh bed leveling grid using a BL Touch. The important thing is that no matter which machine we use, we will have very good bed leveling and strong print adhesion. Extruder and Nozzle. We typically print using a standard 0.4mm nozzle on the Prusa. Although it can be swapped out, the 0.4mm nozzle is a great size for a printer with its print volume. With the Hevo being larger, it would take forever to print using a 0.4mm nozzle, so a 0.8mm nozzle is used instead. This results in faster and stronger prints because the volume of plastic that's being laid down in a single pass is significantly more. Also, for every one layer that is put down with a 0.8mm nozzle, a 0.4mm nozzle would have to lay down 2 layers. Fewer layers means that you're less likely to have as many layer adhesion issues and therefore a stronger print. However, with bigger prints, the prints do not visually look as good, and because the nozzle is larger, the holes are not always as precise and may need to be drilled out. Filament. We typically use inland PLA by Micro Center. We researched filaments and did a stress test of various types of filaments, including PETG, carbon fiber infused nylon, Polymax, and various brands of PLA. We found out the strongest filament was generally PLA, with no one brand being significantly better. For print settings, we found that using 40% infill on 5 perimeters and walls creates the strongest print. We've been able to use printed parts throughout our FRC robot using these settings. We typically print around 210 degrees Celsius. This is around 400 degrees Fahrenheit, so stay clear of the nozzle when printing. Here's a quick chart comparing the printers. You should be off and running now with our 3D printer. If you have any questions, ask a coach or mentor. Until next time, don't forget that you make a huge difference on the team. Peace out.